The concept of alternative propulsion methods in space travel is gaining significant attention, and for good reason. It's an area of research that has the potential to revolutionize our exploration of the cosmos, enabling us to travel farther and more efficiently than ever before. Traditional propulsion systems, such as chemical rockets, have been the backbone of space exploration for decades. However, they have significant limitations. For one, they're incredibly heavy, which means a large portion of the spacecraft's mass is dedicated to fuel, rather than payload or crew. This severely limits the amount of cargo or people we can send to space. This means that spacecraft have limited power and acceleration, making long-distance travel a significant challenge. The amount of fuel required for a trip is directly proportional to the mass of the spacecraft, which creates a catch-22 situation. The more fuel we add, the heavier the spacecraft becomes, which in turn requires even more fuel. Launching a spacecraft is already an expensive endeavor, and the need for massive amounts of fuel only adds to the bill. All these limitations combined create significant barriers to long-distance space travel, making it difficult and costly to explore the vastness of space. Ion drives, on the other hand, are a type of alternative propulsion that's gaining traction. These drives work by accelerating charged particles, such as xenon gas, to generate thrust. Since the acceleration is continuous rather than instantaneous like in traditional rockets, ion drives are much more efficient. They also require much less fuel, making them a more cost-effective option. Nuclear thermal propulsion is another alternative method that's being explored. This system uses a nuclear reactor to heat up a propellant, such as liquid hydrogen, to generate thrust. The high energy density of nuclear reactions makes this method potentially more efficient than traditional chemical rockets. Solar sails, on the other hand, use the sun's energy to propel a spacecraft. While the acceleration is slow, it's continuous, making it an attractive option for interplanetary missions. NASA's Deep Space One mission, launched in 1998, was the first to use an ion drive in deep space. The mission was a huge success, paving the way for further development of ion drive technology. In fact, NASA's Dawn spacecraft, which launched in 2007, used an ion drive to enter orbit around the asteroid Vesta and later the dwarf planet Ceres. Another promising development is the recent test of the nuclear engine for rocket vehicle application, NERVA, by the Los Alamos National Laboratory. Alternative propulsion methods offer a potential solution to these challenges, enabling us to explore the cosmos more extensively and sustainably. Thanks for watching, and I'd love to hear your thoughts on alternative propulsion methods in the comments below.